Hey guys, and welcome back to another one of these aiming for grade 5 papers for foundation. You guys seem to have liked the previous one, so I've come back with another. For those of you that don't know, I am a maths teacher and maths tutor. I've been teaching for a few years, and I'm going to show you, ideally, the exact way to think through the question. So the problem that I find with a lot of foundation students and higher tier students is you know the content, but you're kind of stuck on what to do when a certain question is worded weirdly or differently. So the point of this video is for me to talk through my thought processes, so that way you can really perfect that exam technique and get those top grades in foundation tier. But without further ado, let's go on with it. As usual, I'm going to leave a link to the blank copy of this PDF, as well as the links to all of the other great grade 5 stuff that I've done over the past year or so. But again, without further ado, let's get on with it. First things first, we're starting with a ratio question. Probably not the best thing to start with, but it says on a farm, cows to sheep are in the ratio of 6:5. I personally like to write these out like this, just to make it a bit easier for me to see, although that does, there we are. And we have sheep to pigs as being 2 to 1. 2 to 1. The total number of cows, sheep and pigs on the farm is 189. How many sheep are there on the farm? So essentially what they're asking us to do is to split this number, share it, into the ratio of cows to sheep to pig, and find out how many sheep there are going to be. Again, how do I know this? Well, it's similar to a question where it's like, I have £250, I share it with my friend Paul in a ratio of 3 to 2, how much money do I get? Here's the additional thing, is we don't actually have a ratio for all three of them. We can't share in a ratio unless we have just one ratio. So we need to combine these two ratios. So what you need to think about is, how do you combine ratios? Well, you need to ask yourself one question first. Do they have a letter in common? The answer is yes, they both have an S. So as you can see, this one has an S on the right hand side, this one has an S. Great. How do you actually combine them? Well, what you need to do is you need to make the number associated with them the same. So I need to make 5 and 2 the same. Now I can't really times 2 to get 5, but what I can do is times them both to get 10, because 10 is the lowest common multiple of 5 and 2. So how do I get from 5 to 10? What I'm going to do is times both sides of this ratio by 2, both sides of this ratio by 5. And again, the objective was to make the number associated with the S in both ratios the same. If you can't just multiply one to get the other, then just find a number that does go into them. So I thought of a number that is in the 5 and the 2 times table. The first one that comes to my mind is 10. Could you do 20? Sure, why not? But again, we like to pick the lowest number to keep our numbers nice and easy. But anyways, 6 to 5 now becomes 12 to 10, and 2 to 1 becomes 10 to 5. So my ratio of cows to sheep to pigs is now 12 to 10 to 5. Now what do we do? Well, what we're trying to do is share this 189 in the ratio of 12 to 10 to 5, but we only really care about the sheep, which is the 10 parts. So how many parts do I have in total? I have 12 plus 5, 17, plus 10 is 27 parts. And, okay, just so you know, for these questions, by the way, is it would tell you if it's non-calculator by having this symbol on the question. It was a bit confusing for me too, that they had this just in general, but if you notice with the asterisks, it's only for questions with the with the actual symbol. So this question is a calculator question. So there are 27 parts, and that equals 189. So if I find out what one part equals by simply dividing 189 by 27, so 189 divided by 27 gives me 7. The sheep make up 10 parts. So the sheep equal 10 parts, so that equals 10 times 7, which is 70 sheep in total. And that would be my thought process with ratios. Again, there wasn't anything too spectacular about that one, to be honest, but with later questions you might find that the thought process might get a bit weird and different. As mentioned, we get something that looks a bit weird, is a 5-marker fatty question right here. So we have an oil tank, and it's in the shape of a prism, of course it is, and the front of it, the cross section, is a trapezium, okay? The tank starts off empty and we have oil flowing into the tank, and after 1 minute there's 300 litres. So basically, every minute 300 litres of oil gets added to the tank. Okie dokie. Assume that the oil continues to flow into the tank at this rate. Cool. Work out how many more minutes, that's a devious way of putting it, but more minutes it takes for the tank to be 85% full of oil. Okay, right, mind blown, this is crazy. So, here's my thought process. I need to work out what 85% of the total capacity of this fuel tank is, of this oil tank is, right? Because if I know what that is, I can then work out how many 300s will go into it. So for example, after 2 minutes there'll be 600 litres, 3 minutes there'll be 900 litres, 4 minutes there'll be 1200 litres. I need to know how many litres can actually fit in the tank before I can work out what 85% is. Okay, so the first thing I need is the capacity of the tank, which is effectively the volume. So with the volume, we're going to work out the volume, and it says here 1 cubic metre is 1,000 litres. So then I'm going to turn it into a capacity by timesing by 1,000, right? So how do I work out the volume of a prism in general? Well, with any kind of prism, so you could have like a cuboid like this, you could have a, good lord, that's a horrific one, you could have a cylinder like this. All you do is you work out the area of the cross section. So in this case, that is the front face, the trapezium, and you times it by its length, and that will give you the volume of the tank, or the prism that you have. So again, with any of them, you're working out the area of the cross section, the front face, and then you're timesing it by how long the shape is. So the front face is a trapezium. So how do you work out the area of a trapezium? This formula is on your formula booklet, but it is a plus b over 2 times h. Now you do need to know what a and b are. So let me get rid of this just for a second. When you have a trapezium, I've just realised I don't actually have that much space to do this question, so I should probably be a bit more conservative with it. A and b are the parallel sides, the opposite sides that are different lengths. So they're always going to be these two kind of opposite sides. So in this case, a and b are 3 and 1.4. Does it matter which way round? No, because we're adding them. 3 plus 1.4 is the same as 1.4 plus 3. So let's start with that. 3 plus 1.4, and then over 2 we know. Now h is very, very specific. H is the vertical height. It is not the diagonal length. So it's not these diagonals, it is the actual height. Imagine if you're measuring how tall this thing is. You wouldn't measure the slanted side, right? You would measure the height of it, how tall it is. That's what h stands for. Times by 2.4. Damn, I'm really going to have to be conservative with this. So, let's get to it. So, just putting this into our calculator. Again, it doesn't say it's non-calculator, so I'm going to make my life easy and not bother. And we get 5.28 cubic meters. Now, if you remember, we don't actually care about the cubic meters, we care about liters, we care about the capacity. So this right here, sorry, that's not even cubic meters, that is the area, my apologies. So to get the volume now, you take that area, 5.28, and as I mentioned before, we times it by the length of the prism. So in this case, it would be the length of the cuboid, the height of the cylinder, whatever it is. So in this case, it would be times by 2.5. Here's another good way you can check. Remember when I always say this in every video, they have to give you enough information to do the question, and they never give you extra information. We've used all of these numbers except the percentage, except for this one. So that's how I know it's also going to be the length. So times by 2.5 gives me 13.2 cubic meters. Again, we don't care about the cubic meters, we care about the capacity. Now, if each cubic meter is 1,000 litres, to go from cubic meters to litres, we're just going to times by 1,000, which is going to be 13,200 litres. So, interesting, right? So that is how much oil can fit in the entire tank completely. But the question specifies 85%. Just so you're aware, we actually get 3 marks already. So, we get a mark for the area, volume, and then changing to capacity. We get 2 more marks for working out the next thing. The 4th mark is for taking 85% of 13,200, which on a calculator is actually really, really easy to do because there is a percentage button on your calculator. 85% times 13,200. 11,220. Now, here's the tricky bit. The number of minutes. Now, how many minutes does it take to fill up to this point? Well, there's 300 litres coming in every minute, right? So 300, then 600, then 900, then 1200, and so on. So if I divide those two numbers, the number of litres that I want, by how many litres are coming in every minute, that will give me, this is the number of minutes it will take to get to this 85% of the oil. Now, it's 0.4. Well, we need to round this up, right? But it says how many more minutes. So, the how many more minutes is interesting because don't forget, it says after 1 minute there's already 300 litres. So we actually need to take away 1 minute, which gives us the answer of 36.4 minutes. And again, we took away 1 because it's asking how many more minutes. We've already had 1 minute where there's 300 litres now in the tank. That right there gives me the 4th mark and the 5th mark for actually knowing that you're supposed to subtract 1. Very harsh. So, part B for the 6th mark of this question overall. The assumption about the rate of flow of the oil could be wrong. How could it affect our answer to part A? Well, if it's wrong, then that means the amount of minutes that we said is going to be different. That's it. So for example, if more oil comes in every minute, then that means our time will decrease. So if more oil enters per minute, the answer will become smaller. Now, you can actually say the exact opposite. You could say if the rate decreases, so if it's 200 litres entering the tank each minute, then it will make our answer bigger. Either one will get you the mark, but it says explain how this could affect. You just have to pick if it's bigger or smaller and what the impact will be. That's the key thing there. Question number 3, we've got a little bit of geometry. So we have this arc ABC and it's part of a quarter of a circle with the center O, radius 4.8 meters, AC is a chord, blah, 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 blah. Work out the area of the shaded segment. Okay, so this is kind of like compound shapes, but instead of kind of adding two shapes together, we're actually going to be subtracting them because to work out the area of a segment, you can't actually just work out its area directly because it's not a standard shape that we know the formula of. Instead, what we're going to do is we're going to work out the area of the entire quarter circle, and then we're going to subtract the area, this white area, the area of this right angle triangle. So if I work out the area of the quarter circle, you might be thinking, how do you work out the area of a quarter of a circle? Well, how do you work out the area of a circle? It is pi times radius squared. So if I've cut that in 4, I'm just going to divide it by 4 afterwards. So that's going to be pi. What's the radius in this case? Well, it tells me the radius is 4.8 centimeters. So that was quite nice of them. Over 4. And again, it doesn't have that weird calculator symbol, so we can use a calculator, which is really handy because, screw doing that in your head, right? 4.8 squared all over number 4 gives me, let's call it 18.1. Just round that up. And then we've got the area of the triangle. And how do you work out the area of a triangle? It's half base times height. So the base is of course 4.8, but what's the height of this triangle? It's a good question. Well, if you remember, it's telling me that O is the center of a circle. So O to C is the radius, right? And that's what it tells me. But O to A is also the radius, because that's going to be a point on the circumference of the circle. Like if I were to continue this circle round, that point A is on the circumference. And remember, the radius is always a line from the center to the outer edge. So it's also 4.8. So let's do that. We've got a half. Or you can do base times height divided by 2. Times by a half is the same as dividing by 2. Whichever one you'd like to do. Gives me an answer of 11.52. So then the shaded segment. So by 3 marks, we're going to do 3 steps, so that helps. So the shaded area is just the area of the entire quarter circle minus the area of the triangle. And it says give your answer to 3 significant figures. So 6.58 is 3 significant figures. Well, that was lucky, wasn't it? There you go. And it's 1 mark per line of working out. How handy is that? Population of a city increased by 5.2% for the year 2014. Beginning of 2015, the population was 1.56 million. Lynn assumes that the population will continue to increase at a constant rate of 5.2% each year. Use Lynn's assumption to estimate the population of the city at the beginning of 2017. This is repeated percentage change. How do I know that? What's given me that hint? Well, it says each year. So it implies it's going to happen more than once. And if you notice, 2015 and 2017, that's 2 years, right? 2016 and 2017. So we're not just applying it once, because look, constant rate of 5.2% each year, we're applying it twice in this case. So it's going to happen 2 times. So it's repeated because we're doing it more than once. We're not just increasing 1.56 million by 5.2%. We're increasing it by 5.2%, then increasing that answer by 5.2%. However you want to do that is completely and utterly fine. You can literally just do, 1.56 million, increase by 5.2%, and then get that answer and increase that by 5.2%, and you'll get the right answer. It really will not matter. However, what I like to do is use the formula which you've probably seen used in compound interest. And this is one of those things that kind of bothers me in terms of how maths is taught, is compound interest is repeated percentage change. You might get 2% on your money every year. So you get 2% and then another 2% and then another 2%. It's repeated percentage change, which means the formula for compound interest is the exact same for the formula for repeated percentage change. Identical. It literally doesn't change. So in compound interest, you take your original amount. I'm aware I didn't put the line on A. You times it by whatever the percentage is, and you do it to the power of the number of years, right? We're going to do the exact same thing, but in terms of population, because again, repeated percentage change is the exact same as compound interest, that they are the same things. So we start with 1.56 million, so 1560 and then another 3 zeros. Times that. Now what goes in the percentage? Well, if it increases, it's going to be above 100%, because 100% is just the normal amount. If it decreases, it goes down to below 100%. If it increases, it goes to above. And if it's increasing at 5.2%, that means it's going to be at 100 plus 5.2, 105.2%. That's what that means. So 105.2%. How many years? Well, it's 2016 and then 2017, right? We don't include 2015 because 2015, the population already is what it is. So the growth is going to happen in the next year. This is going to give me 3 marks for subbing into a formula which is really quite easy. And this is true for compound interest as well. It's very short, the formula. It's not that tricky. It's just knowing when to use it and knowing what each individual thing is. And it will come up every single year. I just realized, by the way, there is actually a mistake that I've done. After just saying how easy it is, I didn't actually put the percentage symbol, which I know that might seem like a small thing, but it does have to be the percentage. This would be something that I would definitely make sure that I'm okay with, because it is guaranteed to come up every year. There we are. Goodness gracious. All right, there we are. So that was at 1.726 million. Now, here's the thing. It says there's 3 significant figures. So 173, and then the rest will be zeros. 1730 people. And of course we can't have 0.24 per person anyway. Then it says, use the assumption to work out the year in which the population of the city will reach 2 million. So at the moment we have 2017 is 1.73 million. We want to keep increasing this by 105.2% and tallying how long that takes us. So what we're going to do is we're going to take our answer and we're going to increase it by 105.2%. I can't do the percent symbol, that's a shame. And what we're going to do is every time I press equals, you're going to notice the value gets bigger. So that's one time I've done it. And what it's going to do is it's going to do the repeated percentage change for me. It's going to take 5.2%, add it on. Take 5.2%, add it on. That's still not over 2 million. That's 2 years. There we are. So 3 more years. So in other words, in 2020, it will reach 2 million people. 01. 034 technically. That's it. Now, what about this last part? If Lynn's assumption about the rate of increase is too low, how might this affect your answer? Well, what does that mean if it's too low? It means that this percentage should have been bigger. So it's actually bigger than 5.2%. Well, if we think about it, where did I use that 5.2%? I used it as a multiplier. If I multiply by a bigger number, what happens? The number gets bigger, right? Shocking. Like 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. The number gets bigger as I increase the number I'm multiplying by. So what does that mean about our answer to part B, part I? How long it would take to get to 2 million? Well, it means the answer will actually be less than or sooner than 2020 because it would have increased at a faster rate. It would have reached 2 million sooner. So it would reach 2 people sooner. So in other words, the date will be sooner. That's how you get that mark. So again, so what was the thought process there? Well, they've made a change to one of the numbers. You identify what number they've changed. They've changed the rate. Identify where you use that number over here. Then you can clearly see, or you can more clearly see, what effect that's going to have. That's the process that you take whenever you have, if this is true, then what? Questions. This is some pretty advanced algebra, and as you can see, not allowed to use a calculator. But that's fine because, as you're going to see, it's a lot of algebra. Jesus Christ is all I can say about this. It's quite a lot of stuff going on. But if we read through it, so we have the total height of this shape, we have the radius, we have the radius of the hemisphere as well. A cylinder has the same volume as the solid, so that's a really key piece of information that we're going to use. Find a formula for h in terms of x. So we're not going to get a number as our answer, so that's a really key thing that I want to say. But they're telling me the volume of these two shapes, so this shape and this shape, are the same. So let's get an expression for the volume of each of these. Let's start with the cylinder, because I would say it's probably a little bit easier. The cylinder here, the volume, again, because this is a prism, is going to be pi r squared, so the area of the top thing, times by the height. So that's going to be pi times 2x squared times h. So that would be 2x squared is going to be 4x squared. So 4x squared h pi. Yeah, why not? The kind of ice cream cone thing they've got going on here is a little bit harder. So the volume of the sphere, let's start with that. That is 4 over 3 pi r cubed. R in this case is x, because that's the radius. It tells you here the radius of the hemisphere. But we need to divide it by 2 because it's a hemisphere, not a total sphere. Now when you divide it by 2, something interesting happens. What we're essentially doing is just dividing this front number, 4 over 3, divided by 2. So make it a fraction, keep flip change. So we get 4 over 6, so we get 2/3. So that's one part of it. 2 over 3 pi x cubed. Now with the cone, it says it's going to be 1 over 3 pi r squared h. So we're going to add it on, because again we've got the cone and then we've got the sphere. If you like, we've got the cone of the ice cream and then we've got the actual ice cream bit on top. It's 1 over 3 pi r squared h, so we've got the 1 over 3, that's fine. Pi, r squared, well the radius it tells me is x, so that's x squared. Times the height. Now the height is not 5x, it's 4x, because don't forget we're going to be subtracting the radius of the hemisphere, so it's actually going to be times 4x. So we have 2 over 3 pi x cubed plus a third times 4 is going to be 4 over 3 pi x cubed. So we can add those together and we get 6 over 3 pi x cubed, which is also equal to just 2 pi x cubed. And we know that this thing is going to be equal to this thing. So let's make them equal to each other. We can get rid of x squared from both sides. We can get rid of a 2. We can get rid of pi from both sides. So we have 2h equals x. So find a formula for h in terms of x. That means we're going to have h is equal to x over 2. That's probably the hardest algebra I've ever seen on a foundation paper. So do keep that in mind. That's when you're kind of pushing into kind of the next boundary. But hopefully the individual steps weren't too bad. And for the final question, this is actually a really common foundation question. And the problem is it's always answered quite poorly. And what I like to do is I sometimes make a table out of it just to make this make a bit more sense. So what they're doing is they're combining two metals to make an alloy. So what I might do is do something along the lines of this. I might write metal A, metal B, and then alloy. I'll draw this. And what you need to do is you need to think about what density is. Density is equal to mass divided by volume. If you like the formula triangle, I'm going to draw it down here. That was actually pathetic. Alright. Sorry. Density, mass, and volume. There we go. Of course. Thank you. Thank you so much for doing that, autocorrect. I really appreciate it. That would be kind of your formula triangle for this. No. There we go. And what we're going to do is on the left-hand side, I'm going to write mass, volume, density. And I think this, in my opinion, is probably the best way to lay out questions like this. Because if you notice, there's actually quite a bit of information they give you. And some of the information is not, well, all the information is useful, but it's not presented in the most useful way. So we mix 150 grams of metal A, so metal A is 150, and 150 grams of metal B to make 300 grams of an alloy. Now hopefully that makes sense, right? If you imagine you take 150 grams and 150 grams, when you add them together we should get 300. Cool. It then says metal A has a density of 19.3 and metal B has a density of 8.9, and our goal is to work out the density of the alloy. And to do that, we need to work out all of the missing spaces in our table. Why? Well, density is mass over volume. I have the mass of the alloy, but I don't have the volume of the alloy. So I need to work out the volume of the alloy. But how do I do that? Well, if you think about it, again, just like when we add masses together, we get the total mass. When we mix two things together, their volumes will add. That's why I said if we just work out the missing spaces, we actually can work out our answer. Now, we have the mass and density, and we want the volume. So the way I word it is if we cover up volume, what's left? Well, it's mass over density. So all we need to do to work out the volumes of these metals is take the mass and divide the volume. 500, where did I get that from? .77. Do the same thing with metal B, so I'm just going to change that to 8.9, yeah. That had me paranoid there for a second. 16.85, let's call it. So again, all you need to do is add those two volumes together to get the volume of the alloy. So I'm going to take that, I'm going to add 7.77. We get 24.6 as our volume here. Okay, now we can stop covering up the V and instead cover up D because we want the density. And what is that? That is mass over volume. So it's 300 divided by 24.6. And did it say to give our answer to... No, there's no significant figures. So 12.2 I'm going to call that. And that's it for 4 marks. It's a lot of marks, but again, the mistake that students always make is they don't lay their work out in a logical, neat way. And I even find this, to be honest, so this kind of foundation question is one of those questions that appears on higher as well. So it is higher students as well making these mistakes. You have to lay your work out in such a way that it makes it easy for you to see. And in my opinion, this is the best way to do that. Because it's very obvious. Then all you're doing is filling in the blank spaces of a table. And we've been filling in tables for years now. I mean, especially you guys. Well, especially me. But you guys have as well. I hope that kind of method helps because 4 marks is a hell of a lot of marks. In terms of where you get your marks from, it's a good question. You get your marks from working out the individual volumes and therefore the total volume and then working out the density. And how long did that really take me? Not that long. Anyways, if you would like to see more of this, then do let me know because I can make quite a few more. But other than that, have a really good day and enjoy the rest of your Easter if it is Easter when you're watching this.